Good morning and a warm welcome to one and all. Myself Kaushik, Business Executive at Manage CIA. Welcome back to the 14th webinar of the Saturday webinar series, Agri-Startups on Precision Farming. Till date, we've got a great audience of 1700 plus participants, and there's an update. We shall be having the Saturday webinar series on the loop. So till March 27th, we got all the registrations on the website. So we'll also share the website in the chat box. You can have a look on that. And precision farming is playing a vital role by maximizing the efficacy of crop inputs, which helps the farmers, especially in applying the right quantity of agricultural inputs to the need of a particular field. The use of precision farming is not just for the production of a crop, but also for the improvement of the environment, which reiterates the use of agricultural inputs. In this webinar, we shall be discussing the various techniques and methods of precision farming which are used in the agriculture. I request Dr. Saravanan Raj, Director Agricultural Extension, National Institute of Agricultural Extension Management and CEO of Manage CIA to give the initial remarks.
Yeah, thank you, Mr. Kausik, for unmuting, and very good morning to all of you. And on behalf of Manage, and once again, very happy New Year to all of you, and very good morning to all of you. And today we are having very interesting topic: precision agriculture. As you know, globally we'll talk about there is a issue of nature resource management. Always it's a challenge recent days when there is a population is increasing and agriculture is become more and more intensive, and maintaining soil health and making natural resources become more lively and more healthy one, it is very tough task. At the same time, even when we talk about increasing the farmers' income, it is not necessarily it is increasing the production or productivity, market price or something. Even reducing the cost of inputs, that is very important thing. Reducing cost of inputs and other whatever resources we are putting in the agriculture. In this context, maybe precision agriculture very important topic. Almost more than decade, many universities and many of the research organizations, they are doing great research in precision agriculture. Even Tamil Nadu Agriculture University also, very well they were doing precision agriculture few years, last 1 decade or so on precision agriculture. Like many across the globe, large number of research institutions and scientists, they are trying for making more and more results for the research for the precision agriculture. But today's large number of new age startups are there. The large number of startups, and they really do wonderful job using the precision technology. Even Manage at Center for Innovation and Agripreneurship, we have our own startups which works with the precision agriculture. And those things you can see from our caamanage.gov.in. The link also given in our chat box, you can check. There are our startups. Few of them they are doing on precision agriculture. But today we have very interesting two speakers, Mr. Sailendra and also Mr. Jitendra. Both are very senior people, and one of them is Mr. Sailendra is a co-founder, and Mr. Jitendra Singhal is head of sales and marketing Fasal, and well-known organizations, and they are a part of this precision agriculture, and we like to hear more from them, and I wish the participants can continuously participate in the Saturday webinars, and also you can give some topics if you're really interested. The group of people are suggesting some topics, and where really agri startups need to move forward, something you need some answers, always you can put in the chat box, or you can write to our email. Whatever email you are getting for the this webinar announcement or links you are getting, same link you can send any reply message you want these topics or these things, and we collect a lot of information, and we'll find out the group of people who are asking some type of information, and we'll put the correct resource persons for the further discussion. We can go even some specific webinar on particular day, we can put a lot of questions only. We'll team of experts we may take also, and you can put it and you can make it more interesting. As of now, you can see in our website Manage ca.manage.gov.in or www.manage.gov.in. Already we are some 12 or 13 topics are there already. We updated those topics and you can see those topics. Still you wish some more topics should be covered, and we'll see that it is not for the only for certificate. We may not give the certificate those who are participating only one or two. As usual, out of 12 webinars in coming days, it is coming, you are need to register, and somebody participating 11, that to full time we will give the certificate. Somebody it is useful for them for further any useful, we will give the certificate. Only those participants, those who are participating almost all the webinars are 12 out of 11 webinars, if they are participating, we'll be giving certificates. And with this, I request today's speakers, Mr. Sailendra and Mr. Jizendra's practical inputs. And before that, I'll request our Kausik to introduce the speakers to the audience. Thank you very much. Yeah.
So thank you, sir. Today we got two speakers, and first we have Mr. Shailendra Singh, who's a co-founder of Yuktix Technologies Private Limited. He's obtained his bachelor's in electronics communication and engineering from College of Engineering and Sciences and Technologies, Lucknow. Couple of corporate experiences, and currently into digital agriculture with like next generation wireless sensor network and digital tools for agriculture. He's into product development, embedded systems, Internet of Things, sensor integration, UAV development and deployment. Also deals with market research, business development, marketing, and sales. Request Mr. Shailendra Singh to start his session. Thank you.
Thanks, Kaushik. Thanks for the introduction. Uh, Good morning, everyone. This is Shailendra Singh. I am the co-founder of Yuktix Technologies. Today, I'll be talking mostly on the technology side, and if anybody has any question, they can always put it in the chat box. We are going to have a Q&A in the last. So I'm going to share a small presentation. Please let me know if it is coming in the visible to you.
Yes, sir, it's visible.
Okay, so the today's topic is precision agriculture, and precision agriculture means has multiple verticals which can be used. It can be IoT, it can be drone, it can be satellite, it can be soil moisture sensing. So any vertical which is driven by technology, which is going to convert a normal farm into a smart farm, can come into the precision agriculture. So today I'm going to focus more on the IoT, because IoT is a term which many people are very much aware of. So Yuktix is a agri-tech startup based out of Bangalore. We work into smart sensing for agriculture. So that is very clear. This is some information about where we have been recognized with. I will skip this slide because this might not be of interest to the people who are over here. So this is something that what we are doing right now. So what we do is we are creating next generation infrastructure to collect and analyze data from agriculture sensor. So what we are doing is we have developed this IoT platform which help us to collect multiple type of data from the field. This data can be from the weather sensor, this data can be from the warehouse sensor, this data can be from the sensor which are installed on the vehicles which are moving in the field. We have make ubiquitous computing easy using sensors. So basically ubiquitous computing is where you keep on dropping the sensor, they form a network among themselves and they relay the data to the cloud. Then we have as I mentioned earlier, then we have our own IoT cloud which we have developed from scratch, which allow us to manage all these IoT devices data, manage all these users, create different kind of dashboard, and then do the data analytics to provide the actionable intelligence to the growers or to the farmers. Because for a farmer or for a grower, it doesn't matter that how temperature is going. What matters to him is that what action he should take in order to improve the way he is doing agriculture, which in turn should help him to increase his production or increase his profit from the farm. Then whatever devices we have these devices as a low power devices which should work on battery, which should work on solar power, because in agriculture you do not have a continuous power supply. And then there are multiple situation where you need different kind of communication options. For example, in some location you need wired communication, in some location you need wireless communication. Some component, please let me know if I'm going too fast. I'll slow myself down. Not a good uh, not good in that. So Kaushik.
Yes, a bit slow, sir. That would
Okay.
be great,
Okay.
sir.
So in IoT, what are the components? In IoT for agriculture, what are the different components? So on the one side, we have an agriculture sensor that constitute of micro weather sensor and soil sensor. In micro weather, you have multiple sensor. For example, air temperature, air humidity, wind speed, wind direction, air pressure, uh, then solar radiation. In the soil, you have more sensor. For example, soil volumetric water content or soil tensiometer. Then you have soil EC, you have soil temperature. Then on the agriculture side, you have leaf wetness. You can also have pan evaporation sensors.
Sir, sorry to interrupt, sir. Your PPT is not visible, sir.
uh, I am sharing the PPT from my side. Is it not visible at all? Was it visible earlier?
No, sir. It was visible earlier, sir.
Okay, let me share it once more.
Yes, sir. Perfect.
Now it's visible.
Yes, sir.
Okay. So what I was talking about is that what kind of sensors are there on agriculture side. So we have micro weather in which temperature, humidity, pressure, rainfall, wind speed, wind direction. On the soil side, you have soil volumetric water content sensor, you have soil tensiometer, you have soil EC, that is electrical conductivity, which is used to know if somebody is doing fertigation or not, or how much they are fertigating the soil. You have soil temperature. On the agri side, you also have soil leaf wetness, you have a solar radiation, you can also have pan evaporation sensors. So these are the physical devices which sense the which is a sensor which sense the physical changes in the environment, and they provide the output. Now this output has to be monitored, or has to be processed by a device. So you have IoT devices with different kind of sensor which are used in different location. For example, micro weather monitoring, or in a smart irrigation. Or you have these small devices which come with camera, which can be used to count the number of insects, or number of insects which are coming to the trap. Or you can have field view camera also, which will keep on monitoring the growth stages of the crop. So you have sensor, you have devices which take reading from the sensor. Then you have, in the last, you have IoT cloud, or you have a server to which all these devices send this data. On the server side, your cloud received your application received this data, they store it, and then they process it and make it available via a smartphone application or via a desktop application. So these are the three components when we talk about IoT in agriculture. Now coming more into the what is IoT. So I will take some time over here because this might be helpful to the people who means, because we keep on getting the calls from different people and they want to understand what is IoT and how it can help them in agriculture. So I'll take some time to explain here in detail. So in the IoT side, you have sensor. First, we will talk about the hardware side. You have sensor, as I mentioned earlier. This sensor can be micro weather sensor. This sensor can be soil sensor. This sensor can be the GPS sensor, which can be installed on the vehicles or on the machinery which is used in the farms. These sensors can be your small tags which are installed on the. Kaushik, you were saying something?
No, sir. No, sir.
So
All
these,
good, sir.
yeah, these sensors can be the small tag which can be installed on the cow or a buffalo in animal husbandry. These sensors can be your water pH or water EC sensor, which can be used in the aquaponics or hydroponics side, right? So there are multiple sensor which can be used in IoT for agriculture. Then you have a hardware which read data from all these sensor, which manipulate this data, because all these sensor provide data either in analog or in digital. So in analog, it can be a voltage which can vary from 0 to 3 volt or 0 to 5 volt. In digital, it can be a protocol, for example, UART or SPI or I2C protocol. So you need a hardware, you need a machine, in a bigger, on a higher language, you need a small computer which can read data from all these sensors. Then every small computer or every small device need to have a software installed in that. So hardware is nothing, is hardware itself will not do much work. You need to write some code, you need to write some firmware, you need to write some software on that hardware. So in our terminology it is called firmware. So you have sensor, you have hardware to which you connect the sensor, you have firmware which actually operate on this, reside on this hardware, which read all this thing, which manipulate. Suppose a voltage is coming, so 0 to 5 volt. So what does it mean? If 0 is more like, if you talk about soil sensor which are resistance based, so if you're getting 0 volt, that's mean it is in air. If you put it inside the soil which is very much wet, you will get higher voltage. So you need some firmware which can manipulate that. If 0 voltage is coming, what is that? And if 5 volt is coming, what is that? Similarly, if we have some different kind of soil moisture sensor which give data in a digital interface, still your firmware need to read from that, that okay, what does it mean actual. So now you have sensor, you have hardware, you have firmware. Now comes the communication module. So you read all this value, you manipulate that, but then what? You have to send it to some location. So this is where people earlier were calling M2M and IoT. So this is where M2M is different from IoT. So in IoT, you have sensor, you have hardware, you have firmware. Then you push this data via some communication option to a cloud. This communication option can be various communication option. This communication option can be Wi-Fi or Ethernet or GPRS or even the satellite connectivity. So in India, satellite connectivity is not possible. Government of India has not allowed other company who are operating outside India to use satellite communication. But yeah, that is possible in countries like USA and in Australia. People are using low Earth orbit satellite communication, using which you don't need any kind of GPRS connectivity. You don't need any kind of cellular connectivity. So this was the first part in the IoT, that you have sensor, hardware, firmware, communication module, and IoT devices. Then came the second part, IoT cloud. So what does this IoT cloud? In simple terminology, it is a server where your devices are pushing this data. So IoT cloud manage these devices, manage this device data also. You have something called TSDB, that is called time series database, because this data which your device is sending on a higher frequency. So you need to use a TSDP kind of database. Then you have normal database which is used to manage all these user, or if somebody is creating farm or some other. And then you have worker management. So worker are different kind of computation management which you are doing on the back end. You are making sure that whatever data is entering in your cloud is being pushed to different kind of locations. Then you have API machine. So API machine collect data from this TSDB and make it available to some other computation. So on the computation side, you have AI and ML. That means I think most of the people would know this is very fancy term these days: artificial intelligence and machine learning. So whatever data your IoT cloud is getting, it is being pushed to a computation machine using the API, where you can have multiple kind of computation. It can be simple data analytics, it can be higher machine learning algorithms also, and you can have reporting and alert over there. So for means, suppose if someone is managing multiple farm, they need to get report on daily basis delivered in their inbox in the morning. Okay, that this farm is managing, this farm is doing all the stuff which are required to be done in order to make sure that they get the higher production. And then you have alerts. Suppose if you can put up an alert that whenever the soil moisture in a specific plot in a specific farm is less than this, alert the people who are responsible for doing the irrigation. So this is the competition and reporting and alert part. And then you have front end. So whatever competition we are doing, or any company who is doing on data which they are collecting from the farm, they have to make it available for to the user. So it can be done via web interface, it can be done via a smartphone application, it can be Android, it can be iPhone. So these are the components of IoT. When somebody talk about IoT, these are the major components that come into picture when somebody talk about IoT. So here come the important part, that where I am focusing on today's webinar. What are the application which I can think of in application of IoT in agriculture, which I can think of. So you have pre-harvest when somebody is growing, you have post-harvest when somebody is storing the produce in cold storage, you have hydroponics, you have aquaponics, you have vertical farming, you have animal husbandry, you have dairy, you have farm machinery. So in all this topic, I'll be focusing on the pre-harvest, post-harvest, and farm machinery using some illustration and diagram, which will make people who have joined the webinar to understand how does it work. So I'll start with the pre-harvest. So this is a small illustration which talk about what all sensing can be done in the pre-harvest. So in the right hand side, bottom corner, you can see that there are different devices. A device which is with soil moisture, which is with lux, which is with air temperature and air humidity. You can have a different device which is only with soil moisture and soil temperature. You can even have a third device which can be only with soil moisture. So it is based upon the user requirement, it is based upon the crop requirement, it is based upon the farm requirement, that what kind of sensing is required. For example, in some crop only soil moisture is the most important parameter. In some location irrigation matters a lot, because other thing people are managing, right? So you need to have devices which can provide requirement specific sensing, and these devices are required to be solar powered and battery powered. So you have all these devices, then you can have a weather station. These are small devices which can take only couple of sensors. Then you have a weather station that can take all the sensors starting from rainfall, leaf wetness, air temperature, air humidity, wind speed, wind direction, solar radiation. So these small devices can operate individually using a GPRS SIM or using a SIM card, or they can communicate to a gateway. So this is where a terminology come into picture that is called WSN, wireless sensor networking, or what people nowadays call as LoRa, or what people call as Zigbee communication. So you can have these small devices talking to a gateway. This gateway have a SIM using which you are sending this data to the cloud, or you can have these devices come only with a SIM card so that they are independently talking to the cloud directly. So now, and in the smart farm, you can also have drone based mapping. Drone based mapping is a bit difficult because it need manual intervention, but the kind of resolution you can get using drone is pretty much high. You can in fact get almost like 10 centimeter kind of resolution, or even high. You can also have satellite based imaging, but the only problem with satellite based imaging is that it need a bigger area of interest. The resolution is quite low, so you can in fact get 1 meter resolution, but it's still that is very much low. People use 3 meter kind of resolution. There are some satellite data available which is open to public. For example, Landsat 2A and 2B, I think they provide this data openly to public, but again it's quite difficult to get this data. So you can have satellite based imaging, or you can have drone based NDVI imaging. So all this data is again pushed to the cloud. Then you can analyze this data and can provide the actionable intelligence to the grower, or to the farmer. Kaushik, should I continue? Uh,
Yeah, please continue.
okay. So this is the pre-harvest where people are growing. So there are multiple variable of importance to the people. It can be soil nutrients. Soil nutrient. I think right now there are a couple of company who are doing in real time. I know Krishi Tantra. I know uh, ICR Pusa kit which they have developed to find out the micro and macronutrients. And micro and macronutrients don't are not required for continuous monitoring. Before every crop cycle you can have this testing, and you can use this data to provide the fertilizer recommendation to the user. Then you have irrigation monitoring where you need this soil moisture sensor. Then using the soil moisture sensor, you can also provide the irrigation advisory to the user based upon the crop type, based upon the crop stage. You can also use the ETO calculation and weather forecast to provide a better advisory to the grower. For example, how much water is getting evaporated, what is the weather forecast for next 5 days, and what is the soil moisture. Then using this data.
Shailendra,
Yeah.
sorry for interruption again. A bit slow, sir,
Okay.
because yeah,
Sure. I will go a bit slow. Pardon me
yeah.
for because again I'm not in a habit of explaining these things. So what I was telling is that in pre-harvest you have multiple variable of interest. One variable is irrigation, how you can optimize the water use in irrigation, how you can irrigate a crop in a optimum levels which do not impact its production. If you are irrigating less, the crop will come under stress. If you are irrigating more, the leaching will happen, and the crop will not be able to take the requirement of amount of oxygen from the soil. So this is where soil moisture, ETO, and weather forecast come into picture. Based upon the soil type, based upon the soil moisture level, based upon how much water is getting evaporated, and based upon the weather forecast, you can means companies can provide irrigation advisory to the user: when to irrigate, how much to irrigate. Then you have soil testing facilities which multiple companies are providing. I mentioned the name earlier. Krishi Tantra is a one of the company who is providing this real time soil testing. Then you have your IHR or other government of India Agriculture Institute based soil testing lab, which can provide you soil testing. The result of soil testing can be uh, micro and macronutrients. Then the other important variable in pre-harvest is disease prediction. Can you provide disease forecasting for a specific crop, for a specific disease? This is a bit difficult topic to even talk about, because
Mr. Shailendra,
yeah.
are we on the same slide like Uptix, Anki, DB,
Uh,
or
I'm on the IoT for agriculture slide, which is showing
right?
devices. We are on the same slide. So
Okay,
I was
perfect.
trying to talk here that what are the variable of interest for growers when we are talking about pre-harvest. So irrigation is one. Then you have disease forecasting is one. Then you have soil testing, that is another. Then you have weather forecast, which is being provided by Government of India, IMD, or some other organizations like SkyMet, or a couple of more organizations who have required bandwidth for doing all these heavy computations. Then you have satellite imaging for hotspot detection. Then you have a couple of more variables which can be utilized. So these are the variable of interest when we talk about pre-harvest and we talk about the IoT for agriculture implementation. Moving to the next slide. So this is the post-harvest, when the production has happened and the grower has to store their produce inside a cold storage, or when he or she is transporting the produce from the field to a location in a cold storage. So this is where I think post harvest monitoring is required. That why post harvest monitoring is required? Because even in the cold storage, if the cold storage owner is not maintaining the proper temperature and humidity condition, it is going to impact the quality of produce. For example, I'll take one example over here: potato seeds which are stored in the cold storage. If the air temperature is less than 2 degree, it will start reaching where this potato seedling they are called tubers. So they will start dying. If the temperature is more than 6 degree, it will start sprouting. So this is where very accurate measurement is required in the cold storage for the produce, whose quality can deteriorate if the optimum temperature and humidity conditions are not maintained. So this is where we have so you can see that, okay, you have deep freezer where you need monitoring. You have shipping containers where you need monitoring. You have refrigerated trucks where you need monitoring. You have silos where people are storing these grains, there you need monitoring. And then you have cold storage and warehouses where you need temperature and humidity monitoring. In some cases you also need ammonia monitoring. So this is where the IoT come into picture, that you can have these very small devices which can be totally battery powered, because wiring inside a cold storage is very much difficult, and usually people don't allow to draw wires. So the devices need to be wireless, they need to be battery powered, they need to be long range communication. You need sensing from multiple location. And then on the outside side, then on the output side, the management or the farmer or the this cold storage owners need to be notified. They need to have a dashboard where they can see how they are maintaining the temperature. This is also useful for the warehouse owner also, because if he know that how temperature and humidity are moving inside the warehouse, he can turn off or turn on the chiller based upon those readings. In that way, he or she can save money on the amount of power used in chilling. Moving to the next slide. So this is somewhere where we are talking about the farm machinery monitoring. So you can have different kind of machinery which is used in the farm. You can have different kind of sensor installed in that. One sensor is your GPS, which tell where your machine is. Other sensors can be fuel level monitoring, or a sensor which monitor the health of the engine in that. So you collect all this information, you push it to cloud, then you can have features like real-time tracking. You have fuel level, you have occupancy of machine, if the machine is used or not. You can have different report which can tell the health of the machine using machine learning algorithms and different. So I covered three use cases of IoT in agriculture. This is the pre-harvest, this is for the post-harvest, and this is for the farm machinery monitoring. Kaushik, are we going to take any question, or how much time is left so that I can?
Questions in the last, sir. You can still
Okay,
go ahead with your presentation.
okay. So how much time do we have here?
For you, still we have half an hour, like
Okay,
20
okay,
minutes to half an hour.
okay. I'll conclude before than that. So till here we have talked about the various application of IoT. I have covered three: pre-harvest, post-harvest, and farm machinery. Because we have some time over here, let's talk about the hydroponics, aquaponics, and vertical farming also. Hydroponics, in hydroponics, growers are interested to know about the soil pH, soil EC, and soil temperature. Because if soil pH is moving too much away from the optimum level, it is going to impact the crop productivity. So this is where they need water pH monitoring. In aquaponics also they need aquaponics. I think people are doing potato with aquaponics somewhere in Punjab and in other location. So there also they need this water temperature and air temperature monitoring. In vertical farming also people need soil water pH and water temperature monitoring. So wherever some sensing is required to make sure that plant get the best operating environment, there you can have this sensor. Now uh, here's the tricky part: you cannot sense everything, right? So for example, soil pH need continuous calibration, right? Because it's a chemical process. Similarly, soil EC also need continuous calibration because it's a continuous process. And sensing is not possible for everything. If somebody come and say I need a dissolved oxygen, so those sensors are quite costly. So this is where means the economics versus the application come into scene, that what is possible and what is not possible. In the starting I talked something about the animal husbandry. So this is where someone is who is having hundred of cattle who are in the field. They need to monitor the health of the cattle, right? So they have these small tags which are installed near the neck of the cattle, which keep on monitoring the body temperature and some other variables. Now these tags, they need to be low powered because it is installed on the cattle's neck. They need to be wireless and they need to be a long range, because your cattle, if you have a big field, your cattle can move around in a big field, right? So this is where I think a lot of people are working in Australia, and I think there are a couple of startup in Bangalore also who are working in the similar field, who have these small tags. These tag communicate back to a gateway. Once you have this data, then you can find out the health of the cattle. In the dairy side also, so dairy is more like application of IoT in industry, in agriculture. So there are a couple of startup who are doing pretty good. I think I forgot the name of the startup, but what they are doing, they are monitoring the uh, temperature of the milk starting from the collection center when it comes to the production facility, or their industry. There they have different flow meters which are monitoring the amount of milk which is flowing through this pipe. They have these level meters which are monitoring the level of the milk stored in big containers. So I wanted to touch base upon all these verticals where I think IoT can be utilized. Uh, I will go to the real installation where we have done. So these are some of the installation which we have done in the remotest location in India. So you can see these are small devices. So the white color box which you can see in the bottom is the actual IoT device. It has the hardware. Hardware has the firmware, and then you can see some connectors go on the right hand side photo. You can see some connectors going on the top side. You can see a black color kind of this device. So that is a rainfall sensor which monitor the rainfall. Below that, you can see some circular shields. So these are solar radiation shield, which in-house the air temperature, air humidity, and air pressure, because you want to monitor the air temperature instead of direct temperature. And then you can see some wire going below. So these are the soil moisture sensor, which go inside the soil at a specific depth. You can have couple of sensors also, you can have single sensor also. Again, it depend upon the kind of crop we are monitoring. Some more example here, you can see some more sensor. On the top left side, you can see wind speed, wind direction. Then you have again rainfall, temperature, humidity, pressure, soil moisture. In some of the location, because the crop need a leaf wetness, we have used leaf wetness also. Now these are the some of the small devices that we have used for open field monitoring and in smart irrigation. One more example of the device which we have used, which was only for soil moisture monitoring, because this is a cotton field. So there they want to monitor that what is the amount of water in the soil, or soil volumetric water content, and then provide the irrigation advisory to the farmer, because this was a drought prone region. They didn't have too much amount of water, so they want to have an optimum use of water in the field by measuring the amount of soil moisture. Another example where you can have multiple sensors. So here you can see that these are the small dots which you can see in every field. So so some crops, for example, banana or sugarcane or even cotton, these are water intensive crops. So this is where you want to monitor the soil moisture and use it very optimally. And if the location where this cropping is done, if they have less water, so you want to irrigate very precisely. So you can have multiple sensor. These multiple sensor can have two depth soil sensor. So you can see there are multiple sensor. They are communicating back to they can either communicate directly to the cloud using a sim, or they can communicate to a gateway which have the same, and that gateway communicate back to the cloud. So this is just an example of where multi location sensing is required. The deployment in a greenhouse. In a greenhouse, you have certain variable which are of interest. For example, lux is an important variable, air temperature, air humidity is important variable, CO2 is another important variable, and then you have this soil moisture. So this is a capsicum field, if I am correct. Yeah, this is a capsicum greenhouse. In capsicum, soil moisture, temperature, humidity play a very important role. Lux is also important, but again, usually people don't go with lux for a capsicum. So based upon the crop requirement, you can have different sensor combination. Now these are some of the open field. On the top left hand side, you can see a wireless sensor which come with leaf wetness, temperature, humidity, and soil sensor. In a gray field, then you have different other sensor. So some example of how these devices can be. Now you need to this is what I was talking about, that on the one hand side you have devices, on the second hand side you have IoT cloud, and or you can call it server. On the third side you have something which come in front of farmer or grower, what they will see. So this is a dashboard on which the grower can access his farm details, his farm micro weather, and the actionable data. Some more example of our deployment. This is also a this is what we have done for cotton field. So we deploy this multiple wireless sensor which communicate back to a gateway. So top left side you can see one device, then bottom side you have another device, then several kind of small devices which come with only soil moisture, and then on the right hand side top you can see a weather station, and then you can see a big pole in which you can see the gateway installed. So this gateway communicate back to all these small devices, and using the same it communicate back to the cloud. So you have weather station, you have soil moisture sensor installed in different location. So you can very accurately tell the growers in their respective field when they need to irrigate and when they don't need to irrigate. As well as with the help of weather station, you can tell them the other variables, for example, the weather forecast, the ETO calculation, and the disease prediction. One example of what we at Yuktix have done when we are dealing with tribal farmers. So I will not go into that because I think I only have 10 minutes left. So I will skip to the next slide. So this is the slide where I wanted to emphasize, where using this case study you can understand the end-to-end implementation of IoT in agriculture. So you have a company who produce these seeds. So we are talking about from producing a seed to getting the produce to a factory where this produce is utilized to to come up with something, right? So you have greenhouses where they cultivate the seeds using tissue culture. Now inside the greenhouse they need to monitor that are these tissue from this tissue culture, can they have these saplings. So they need to monitor very precisely the temperature, humidity, the lux and the CO2. Now this sapling has to be put into the field for the replication. So people who are from agriculture will understand that what is seed replication. So you have sapling inside the greenhouse, these sapling are transferred to the seed for seed replication. Now after the replication of these seeds, they need to be stored in a cold storage, because the harvesting happen only in seasons, right? So if somebody is producing these seeds in the month of January and the harvesting and the planting in the field start from the month of October, so for that specific amount of time these seeds need to be stored in a cold storage. So inside the cold storage they need to monitor the temperature and humidity, because if temperature and humidity is not monitored, or if it's fluctuating, if it is going beyond the specific range, it is going to impact the seeds will die. Now comes the part where they have to transfer these seeds before the planting in the field from one location to another location using a vehicle. So this is where they want to monitor that the vehicle which they are using to transport these seeds to the field is it where it is moving, right? Means where it is at current stage. Is the vehicle store placed under the shade, or if it is a refrigerator, so are we is the vehicle driver maintaining the proper internal environment or not? Because many vehicle driver, they turn off the vehicle, and then again the AC which is maintain the temperature inside the refrigerator goes down. So this is where they want to monitor during the transport of seed to the field, not during the pre-harvest. When they are planting these seeds in the field, they want to monitor the micro weather, how micro weather is moving, what is the soil moisture, what is the soil EC, what are the other soil micro and macronutrients. Based upon that, they can recommend the fertilizer combination to the farmer. Right now they have soil temperature, they have soil micro and macronutrients, they have micro weather. Using this they can they can forecast the disease. And at the same time they also want to know the weather forecast, because weather forecast and micro weather and soil moisture is going to help them regulate the irrigation to have the best and optimum irrigation, right? And then using this micro weather they also have disease forecasting. So all this is helping them to have the optimum yield from the field. Now once the production is done, they have to transfer this produce from field to the factory. Again the same thing, that they need to monitor the vehicle status, vehicle internal environment also. So this is one case study that we have done for a corporate, where we think, okay, we have used IoT from end to end. We have used IoT in a greenhouse, we have used IoT in the cold storage, we have used IoT during the transport, we have used IoT during the during the production or during the pre-harvest also, and then we have used IoT in the last for transferring the produce from field to the factory. So Kaushik, I think I am done from my side.
Okay. So, one request was there from a participant. Would you like to explain regarding farm machinery a bit more?
Yeah, so farm machinery we have done for one of the government organization in Northeast India. So farm machinery, I will come back to the slide. Kaushik, is the slide visible to you?
Not yet.
Okay, I think I stopped sharing the slide. Let me share it once more. I hope it's visible
Yes.
now. Okay. So farm machinery, there are multiple variables. So one variable is the location where the machine is. Second important variable is the occupancy, right? Is the machine used or not? So if the machine is not on, you can always sense the machine is not in used. Third is the fuel level. What is the fuel level of the machinery? Means because these kind of things are important in India and outside also, because based upon the fuel level they can find out how much fuel is utilized, or is the machinery utilizing too much amount of fuel, or in some very specific cases if somebody is stealing the fuel, right? Then come the point where you want to monitor the health of the machine. Is machine vibrating too much? So this is where a, some combination of industrial IoT and agriculture can start coming into picture, that you have this vibration sensor which sense in a specific spectrum if the machine is vibrating too much as it is supposed to vibrate. Because when you are dealing in the field, your machine will definitely vibrate, but is the vibration in a specific location even beyond a specific level, right? So these are some of the important variable that somebody would like to monitor, is specifically government of India, because government of India was doing this smart farming in northeast, where they were making this machinery available to the users via their platform. So it was more like on a rental model, that a farmers can raise a request, they can have this machinery deployed in their field. So government there need to monitor multiple variables. For example, if the machinery is given to the farmer, is he even using the machinery or not? Is the machinery in proper condition? Where is the machinery, right? And they can use this all this information to optimize the use of machine, to increase the health of the machine, and to make this machine available to the maximum number of users. There are multiple startups who are doing work on this. I think there's some tractor startup who is in India. Then there are a couple of more startup who are providing this machinery on rent, and at the same time they have devices installed on this machinery, using which the startup is monitoring where his machine is it being used or not, what is the fuel level, and all those things. Kaushik?
Yeah, I was thinking like, can you just review like, because in
Okay.
the starting it was a bit fast and
Okay, again, I apologize for that.
yeah.
My bad. So from the very starting, we covered, okay, what we do at Yuptik. So we have this infrastructure to collect data from this sensor. We have these low power devices with multiple communication option. We have this our own IoT cloud. Then what are the component of IoT in agriculture? So we have this sensor. We have sensors from micro weather and soil. We have these IoT devices which are used to monitor the micro weather, or which help us to do smart irrigation, or even insect counting, or the growth stage of crop. And then you have the IoT cloud or IoT server, or we can simply call as server, which is required to collect data from all these devices and manipulate this data, compute this data, and provide the actionable intelligence to the user. When I talk about actionable intelligence, it can be weather forecast, it can be disease forecast, it can be optimum irrigation advisory, it can be fertilizer recommendation, or it can be even image based analysis. In this slide, I tried to cover the basics of IoT, the sensor side, the hardware, the software which resides on the hardware, then communication module. So all this combinedly called as IoT device. On the IoT side, I tried to cover the database, how data is being managed, then something about API machine, then something about what kind of computation is possible using AI and ML, and report and alerts, and then what a person will get in the last on the web and on the smartphone. And these are some of the applications which I tried to cover: pre-harvest, post-harvest, hydroponics, aquaponics, vertical farming, animal husbandry, dairy, farm machinery. And then this was a illustration in which I tried to show that what kind of sensing is required, what kind of variable are of importance to the grower. These variable depend upon the kind of crop somebody is growing, or the specific use case. Some people might only be interested in the irrigation, for example in sugarcane, in banana, in cotton, or in the coconut farms also, right? There water is the most important variable, so there they need to have this smart irrigation. In some location, for example grapes, means a lot of people means almost like everybody know about grape, that okay, downy and powdery mildew are the most important, are the most crucial disease which damage a lot to the grapes. So why disease prediction is required? Disease prediction is required to help grower spray less and spray only when it is required, right? So how you can do the disease forecast? All these diseases happen in a specific environmental condition, so if you can monitor them, you can forecast that right now is the highest possibility of disease happening, right? Then you have these satellite based images, and all this data is then sent to the cloud, where it is put in front of the grower or the farmer in a way that they can understand. In this slide, I try to cover where IoT is used inside in the post harvest when somebody is storing the produce. uh, and then why devices are required, why IoT is required. People have been doing this thing from long back. It's not like, okay, people were not sensing, but IoT has disrupted the way sensing is done. Earlier it was mostly the wired based sensing, it was mostly DC powered sensing. With IoT now, these devices are wireless, these devices are battery powered. You can have multiple devices. The cost factor has come down. This is the slide where I try to cover how IoT can be utilized in farm machinery monitoring. I try to show some of the real implementation where we have deployed uh, these sensor are deployed, and if user can people who are attending this webinar can correlate, okay, how these devices look like. So these only have 5 sensor. These devices can have more than five sensors, or even some other sensor. Now in open field, how these small devices can be used. So this is one of the soil moisture sensor that we have deployed. It only come with soil moisture. It is totally battery power. It was totally wireless. And this is where I wanted to show that, okay, how these small battery powered devices, wireless devices, can help growers to monitor from multiple locations. How IoT is utilized inside a greenhouse. Some more example of the deployment, so that people can correlate, okay, how the device look like. Then the software which is made available to the user. Another example where we have done multiple location sensing for soil moisture. We have a weather station, we have a gateway. Using the soil moisture sensor value, using the weather forecast, using the ETO value, we provide the irrigation advisory to the farmer, and as well as the weather, disease forecast. This slide I didn't cover because it was a bit different. It was here we have helped the NGO to adapt the new technology, and the NGO was working with the end farmer. So we have enabled NGO with the latest technology, using which they are now able to improve the advisory they were providing to the tribal farmers. Now, this was the last slide where I tried to cover the whole implementation in the agriculture value chain, from the greenhouse where somebody is cultivating the saplings, to the seed replication, to the cold storage, during the transport, during the pre-harvest, and from after the production, when the produce is transferred from the field to the factory. Yeah, Kaushik.
Yes, sir. Yeah, that was great. And smart agriculture is going to become the next level for everyone. So, IoT is set to push the future of farming to the next level. So, and thank you for the session. We shall go with the second speaker, Mr. Jitendra Singhal, who is the head of sales and marketing for Fossil, an accomplished professional with 13 years in leading teams, sales operation, marketing, product management, and retail experience in key agriculture markets, first-hand exposure to major agriculture markets, agronomic practices, and the product needs of farmers in various geographies. He's well versed with agronomic practices of various areas, dealt with rural customer and the agriculture needs. He's got skill in managing the assigned product categories and full line marketing venues. He's got his ABM, that is Agribusiness Management from Symbiosis International University. Request Mr. Jitendra Singhal to start his session. Thank you.
Yeah, am I audible?
Yes, sir.
Yeah. So, good afternoon, everyone, and thank you, Kaushik and Dr. Saranan, to conduct this session. And it was really good to hear challenge, and I appreciate that he has covered the entire IoT very well. So, I will be speaking more on the pre-harvest smart farming in the entire value chain. So I'm Jiten Singhal, as introduced by Kaushik. I head sales and marketing for Fasal. Yeah. So yeah, so I just want to keep this session little interactive. I know there are limitation of speaking because people are on mute, but I would appreciate if people uh, keep sending messages on the chat box wherever there are queries. So next, so precision farming in India, we already know and we have heard, and there is a lot of book around this around in agriculture, that how can agriculture be more precise using smart technologies. So, as you already know, this graph denotes the requirement of precision farming in India and obviously across the globe, because the population is going to grow by 2025 to be around 10 billion, and we need almost double food to feed the population. But we have limitation in terms of lands, so the only option left with us is to improve the productivity of agriculture. So, as you all know, this is a complex problem to solve, and all of us have some answers to this. That how should we improve the productivity in agriculture? So, can you guys think some of the big challenges we have in Indian agriculture? Just, I mean, if you can just send on the chat. Kaushik, can we do this way, or should I continue by just sharing what I have?
Parallel, it can be done. The audience can share their questions in the chat. And then, like
Yeah.
Q&A can be done in the last. So that's what we think. So the topic should be
Mm,
focused.
no problem. No problem.
Yeah.
So some of the biggest challenges, as you already know, are climate change, guesswork in decision making on the farm, and obviously the poor resource utilization. Right? So we have abundant resource provided by the nature on the farm, but we hardly know how to optimize the resource utilization. And obviously, climate change is also taking big shape day by day, and that's also impacting the productivity of agriculture. And that one of the biggest issue that we see on the farm, especially in the Indian farm where land holdings are low, the guesswork in decision making. So our farmers, our growers are well experienced on what they are doing, and based on their experience and their hunch, they basically take decision. So they do not know how much precisely to irrigate or to spray on a farm for a particular disease or pest, but his guesswork basically takes a major part the farming. So this is something that uh, on the climate change also, there's something that everybody is talking about, whether perhaps has a direct impact on the crop yield. Extreme dry and wet condition, rainfall, all lead to decreasing crop yield, increasing disease and pest attack. I think we are aware this locust attack, recent attack in different region, which destroy a lot of crops. And yeah, so how to cope up with this issue, and how can farming be more precise and more productive? We'll talk more on that. uh yeah, so these are just some of the illustrations. So let's say, what is the level of moisture in my soil? um, 6 or 12 inches beneath the surface. What is the current microclimate condition on my farm? Is it optimum for my crop or not? Are my crops safe from my disease or pest attack? So data today helps taking these decisions. So using data, basically, they make more informed. They make farmer more informed about the technology about his farm, and that is why farmers are able to take right decision, which today otherwise they take on a experience or on the hunch. So microclimatic condition are the local atmospheric condition of your farm. I'm sure all of you understand what microclimatic conditions are. So this is a type of data needed to make informed decision related to irrigation, pesticide sprays, application of fertilizer, application of fungicide, etc. So there are basically some of the key technologies which Shailendra also spoke are being used currently on the farm, which is basically satellite imagery, drones, sensors, GPS, and so on and so forth. So uh, I would be talking more on the benefits of precision farming, which basically we do using technology and using sensors on the farm. So what is precision farming? So basically precision farming in simple language, if you talk about it, is basically uh, to to precisely used of water, precisely use of your fungicide, precisely use of insecticide. So when you have information about the farm, when you know what your crop actually wants, does your crop want to be irrigated by 5 liter or 3 liter or 1 liter? When you have this data and when you take decision based on this data, that is called the precision farming. So how does it help? Obviously it helps in optimizing optimizing resource utilization and cost saving, increasing crop yield, export quality produce, and sustainability. So I'll talk a little on optimizing resource utilization. In India, we believe that that more is better. You put in more fertilizer, and the crop will be nourished better. Supply more water, and the crop will be grow more. In fact, excessive use can have an adverse effect on the crop. I'm sure all of you agree to this. So when you do not know how much to use, you generally assume that the more you apply, the more will be the produce and more will be the quality. The idea of precision farming is to optimize the uses of water, pesticide, fertilizer, and other agriculture input depending upon the crop, soil, weather requirements, so that these inputs don't go waste and degrade the soil or destroy the crop. And obviously when you optimize the use, you actually save on your cost. And sometimes we have seen cases where costs are reduced as high as by 70% to otherwise what he was using. And obviously when you have when we use your precisely in the manner what crop needs, the product quality is also good, the crop yield is also good, which generally growers do not realize when they use products on basis on their experience or basis on their hunch. And these smart farming or precision agriculture is being high adapted in a product where growers and where the crop is for export. So their the major requirement, key requirement, is to produce something which is of high quality and can meet the standards of exports. By using this precision farming, obviously soil degradation can be avoided. The rate of decrease in water level will reduce, making agriculture sustainable in the future. And as I said, to meet up the demand of 2050, you need to grow more to feed people, and obviously you need to be more sustainable in what you're doing. So in nutshell, I would say a precision agriculture will help the farmers in grow more and grow better. Yeah. Yeah. So, Fasal, what we are doing in Fasal is an IoT-based intelligence platform for horticulture crops. It captures real-time data on condition from farm sensors to deliver farm specific, which we just seen in the presentation, and the crop stage, and it gives you farm specific, crop specific, and crop stage specific actionable recommendation to the farmers via mobile phone in vernacular language. So we have these alerts or these advisory available in Hindi, English, Marathi, Gujarati, and in the language which is easily understandable to the farmers who is using it. So, as I said, what does Fasal do? Fasal is into precision irrigation, precise disease and pest management, microclimatic forecast, dynamic crop activity planning, farm finance management. This is very interesting, and you will appreciate that when a farmer who is investing so much on the crop, and at the end of the season, many of them are not aware how much they have invested and how much they are earning, right? They generally rely on the money that they are getting, but they do not actually calculate what they have invested, right? So what we are doing in Fasal provides we have a IoT device which is installed in a farm, or one device, let's say, is deployed for about a hectare area, and it has multiple sensors which captures variable which are responsible for any weather condition, which are responsible for soil stress, which are responsible for any disease or pest. So we are able to capture all those variables from the farm by putting this device on the farm, and these data then are used on machine learning, and then there is a algorithm for each crop which helps farmer to decide how much to irrigate and when to irrigate. And this is water is something, when water is something, when farmer is aware that he needs to only irrigate 3 liter per plant, which otherwise he was irrigating, let's say, 5-6 liter per plant, not needed. And when it is explained to farmer, he also appreciates it, and he sees the result that the crop growth and the product quality is superior than what he was getting. So Fasal provides precision irrigation advisory, and the system continuously checks current soil water tension to ensure that water requirement in the crop is precisely met at all time based on the crop, its stage, and its water requirement. We actually captured GDD, one of the phenomena which I'm sure most of you must be aware, which is responsible for any stage of the crop. So that relates to the stage of the crop. So we are able to capture that GDD in our system, and because of which we are able to tell that what stage that crop is at that particular stage, what is the water requirement, and when he needs to irrigate. Fasal disease and pest prediction system also inform farmers about the severity of crop disease beforehand, so farmer can precisely time their prevention spray, and timely preventive sprays protect from disease and maintain residual limit for export crops. And obviously farm Fasal, this device and that the complete business provides a farm specific microclimatic forecast to keep the farmers well prepared for the weather risk for the future. And as I said, this particular apps also let farmer record all the expenses he's doing for the crop, and when he's selling the crop in the market, he can record the earning, and he can then understand how much he has actually earned from that particular crop cycle. So, in nutshell, farmer can manage sales expenses and cash flow to ensure the health of his finance. Yeah. So, how Fasal works? So, this is a device, as I said, it captures different variables by help of sensors. And in the middle, if you see, that's a box which is basically a motherboard, and it all the data is captured here, and it then communicates back to the office, this particular box. So whatever data that we collect, we send that to the machine, and then basis the algorithm that we have prepared for different crops like pomegranate, grapes, citrus, chili, capsicum, banana, apple, and then it for any for that specific crop that start giving advisory to the farm, and you can say that it then communicates to back to the machine, and then all the advisory is sent on the app, on the farmer's phones. Yeah, please. Next. So because of using this IoT device and this complete Fasal device, the farmer, we have seen that farmer is able to save almost 20 to 30% in water, and it sometimes goes as high as 70% in his spray cost, he is able to reduce cost by 18 to 25%, and we have seen cases where it is reduced by 60% as well. And I said that it also indirectly impacts the yield, where average yield is improved by 8 to 15%, and not only the yield, but the quality of the product is also improved. Yeah. So, so having said that these devices are so helpful for the farm, and these are so helpful for the Indian agriculture, and we have proven results as well on the farm, and we have proven that as high as 20,000 acres so far. And so, in spite of that, the adoption has been slow, especially in India. I'm sure you must be aware this concept of precision farming was launched way back in 1980s in USA. And India, we have just started talking about it. Many startups are playing key role in this space. For past 3 4 years, it's been a good journey. Uh, that people are at least talking about precision farming. The benefit of precision farming makes it imperative to let go the traditional practice to meet the future requirement. But still, the biggest challenge, if I would say, for precision farming is the adoption rate, is to make people aware what precision farming is to break those myths what growers have. So today also, if you go and meet farmer grower, you explain about precision farming, they are still, many of them still happy what they are doing. But I'm sure with the time, with the as the learning curve improves, it will slowly, the awareness and the adoption rate will improve coming years. And yeah, so we have a technology, and the question is, how do we then scale it up? So as I said, future is to reduce the learning curve. People like you who want to be entrepreneur, who want to be uh, uh, part of this journey. The key challenge will be to reduce the learning curve. Improving the internet connectivity, obviously, it still remains a challenge, though the penetration of internet and penetration of smartphone have increased in past 5 years in rural areas as well. But still, it remains a challenge when your consistent internet connectivity in this area needs to improve, to increase the adoption of this technology. And obviously, people like us in Fasal, we are also working on affordable technology. So just to give you a number, maybe 2 years back, what cost we are giving to farmers, we are almost x, that if that cost was x, we are now giving that technology at x by 3, so we have reduced it by one third. But still, this remain a challenge. So we are, let's say we are catering to horticulture farmer, how do you make this technology so affordable so that you can go and uh, improve and go and penetrate this precision farming in field crops as well. So that will remain a challenge for us. Yeah.
Hi, Yuvraj here from Manage, Jitendra.
Yeah, Yuvraj.
So there are a couple of questions, with a generic as well as specific to Fasal. So I'm going to summarize the questions in a single question so that you can address them.
Sure. I'll do that.
So basic question is asked by what can be the minimum area to adopt precision farming? Can it be applied for all types of crops? So what kind of a pricing is done by Fasal? What is the minimum area to take the service of the Fasal? These are the basic questions by the startups. Can you please
Sure.
elaborate on the?
Sure. I'll address those questions. So what we are doing currently, the technology that we have, and obviously we will keep innovating it. But the current technology basically caters to about hectare, right? So which is about 2.5 acre farmland, and that costs to about 40 to 50,000 rupees in a year. And that the life of this particular device is about 3 to 5 years. So where we are able to give crop advisory, throughout the season.
Okay. Then one more thing. So what kind of crops you are covering now? Can it be used for nuts like arca nut?
Yes, yes. So currently, so Yuvraj, a very good question. So currently, we are covering almost 10, 12 crops, horticulture crops, and we are slowly developing other crops as well. So we are into pomegranate, grapes, sweet capsicum, chili, apple, tomato, and we are also working in some other crops like you said, areca nut and cardamom. These are some other crops are in our roadmap. So uh, maybe in couple of months or so we would be able to address these crops as well. So our plan is to basically capture the entire horticulture geographies in India at least for next couple of years. And as we improve on technology and we work on reducing the cost, make it more affordable to farmers, we may you never know, we may go to field crops as well, because I'm sure all of you understand this. uh, the psychology of a farmer who grows horticulture crop and who grow field crop differ, right? So farmer who can invest as high as 2.5 lakh rupees in a hectare in a horticulture crop, it farmer who grow field crop, he does not think of investing this much amount, right? Because his earning is also not much as a horticulture crop grower farmer earns.
Thank you, Jitendra. Please carry on. If once I get a couple of group of questions, so we'll reconvene.
Yeah, yeah. So I was saying this, in precision farming, uh, maybe the need of the time is to, I'll just repeat the same what I was just sharing, that the need is to improve the awareness, reduce the learning curve of growers. And I'm sure this because I am from crop protection industry, right? I worked almost 10 12 years in crop protection. I know how a farmer uses pesticide, let's say fungicide or a insecticide in a, let's say, crop like grape, right? I'm the per acre pesticides spent in grape crop is as high as 70 80,000 rupees, right? But sometimes there is no need to spend this much amount. So precision farming helps him decide how much he has to actually spend money in crop, so that his crop is also well, it is uh, the MRL is also low, the residue is also low in that particular crop. So the precision farming will help improving the export quality, meeting the standards of countries where grapes or other crops are exported. Yeah, that's my side, Yuvraj and Kaushik. Maybe any question I can address.
Yes, sir. Thank you, sir. Precision farming will remove the guesswork and it will help the farming for future. And we shall go for the Q&A. Like we have got a couple of questions initially, starting with the questions are open for both the speakers. Initially, it was asked for Mr. Shailendra. So, can the IoT technology be used in any country, and what are the requirements for the installation? Mr. Shailendra. Mr. Shailendra, please unmute. I think some technical issue. Meanwhile, we can go with.
Meanwhile, Jitendra sir, there is a one specific question by one participant. How are you addressing the farmers who are not well educated? Because most of the farming sector people, you cannot promote them directly. How you are planning to promote your programs to them? So there is a question by a participant you are asking. So how?
So okay, Are you asking about how are we planning to educate farmers about new technologies?
Yeah, yes, one is educating them. Second is how you are convincing them to implement, especially these are being a small and marginal farmers.
Yeah.
How you are going to do this? Because this answer would help all other participants also, because there are many, especially the kind of participant we are having. They're not, even though they're not directly farmers, many of them, but they're stakeholders in the entire ecosystem. They'd be able to convince the group of farmers or FPOs. So we're able to elaborate on how you are going to, your programs are going to be implemented for small and marginal farmers, or how it can benefit them. Probably that will help them to convince them to come to smart farming.
Sure. So, I just mentioned that for now, we are also working to make this technology affordable for small and marginal farmers as well, right? So, obviously, it is a challenge in not only the small and marginal farmer, but farmers who we consider progressive, and he's doing farming for years. It's still a challenge to convince him as well. So, what do? We have actually deployed a few demo distinct devices in the area where we think it can be useful for now, right? And then we demonstrate the results of that particular crop to the farmers who are basically growing that crop. So this is the one of the best methodology that we see is useful to educate them. Obviously, second is we are validating our results and sharing to the growers. Even if he is not using devices, we are also sharing our results with them, that these devices or smart farming, precision farming has been helpful to save on cost and irrigate. This is second. Third is obviously the existing user who has experienced it and who has completely end to end used the device. He is the best person to share his experience with the co-farmers. So that's couple of methodology that we are doing. But answering your question of small and marginal farmer, what we are doing, we are working internally to make this technology more affordable for small and marginal farmers also. As of now, we are not able to uh, bring the cost to the level where the marginal farmer can also afford. But I'm sure maybe time to come, um, the small farmer will also be able to use the technology, and that is where the land holding will play a key role. I don't know, maybe new farm bills, as you already know, these will also be helpful for each farmer to be more these more exposed to the newer markets. He'll be able to maybe earn more, he'll be able to maybe afford these technologies to produce more. So these are some of the ideas that I can share.
Yeah, for Mr. Shailendra,
Yeah,
so what are the requirements for installation of IoT technology? That was the question.
that so I have recorded the question. If we have entered into the Q&A, means people have asked question in the very starting,
Okay,
and so I have recorded the question. I can answer them one by one, but whatever Jitendra has mentioned, I like to add something over here.
sure.
Adoption of any new technology always takes some time. Still remember in 2001 there was this smartphone, right? And right now, after 20 years, we can see that even the farmers or even the rickshaw wallahs has a smartphone. So even the smartphone technology, which is manufactured in lakhs of quantity, which is mass produced, took 20 of times to get to a common man hand, right? The similar is the case with the precision agriculture. It will take its own sweet time. Government of India and multiple NGOs are working at their own level to educate people via different mediums, going and talking to them by running different kind of planning plans all across. That okay, that if we use this thing, this thing can be done. You can see multiple videos by different NGOs, even by companies also, which are educating what is the real use of this. Now, when coming to the marginal farmer who is having a land holding size of 1 acre or 2 acre, there are different ways, there are different level in which precision farming can help them, right? As we discussed, Jitendra also discussed, I also discussed that there are different variables which are of important, right? Soil moisture is a hyperlocal variable which is required to be measured in a specific field, but there are certain variables which will remain same in a bigger geography also. So can in the very starting something can be done using those variables, and some actionable information can be provided to the farmer so that they can get to start using the precision agriculture or actionable intelligence. Later on, stage by stage, when farmer will get to know that whatever he or she is investing in technology is helping him to get double the what he is investing within a year, they will invest, because we I think everyone who is a startup will go and talk to farmer. When you talk to them, when you listen to them, they always say that if anything is helping me to reduce the losses or improve my yield or save the money I'm investing in doing the farming, why will not I pay now? Miss, it's a bit complex thing that how you can make it available to the nth farmer, to the smallest land holding size farmer. So I think this is where government intervention will definitely play a major role, and I think government is trying it level best, because everybody know farmers are the one who feed us, the whole country, right? And in fact, if you talk about the greenhouse or the product cultivation, their government of India is providing subsidy, but again, that is on the higher side, that only rich people can do. So I think this question, I'll start with couple of question in the starting. Hydroponics and vertical farming, what how IoT can be used over there. So in hydroponics, water is the most important variable. In water pH, water temperature is the most important. So if somebody can measure water pH, water temperature, water EC, people can regulate the amount of NPK they're adding in the water, which impact, because in hydroponics most of the people use NPK, right? So if you are measuring the soil EC, the water EC, the water pH and water temperature, you are making sure that the plant are getting the best optimum environmental condition. Then somebody asked about data storage in the device. So this is very technical question. So data can be stored in the device on a SD card, as well as these devices have synchronization facility also. Suppose right now there is no networks, the device should keep on storing this data, and once network is back, it should push data back to the cloud. At the same time, this data should be stored in the device. So you have this SD card, a single device data is almost like 140 bytes, so you can have a storage of almost like 1 to 2 years on the SD card. Then soil organic or not organic, I don't have much insights on that. Probably here Jitendra ji can provide his input, that how some means one input I can provide is soil testing, but again that is continuous soil monitoring is not required, I think. Jiten ji, you want to add anything over here on the on the soil organic part, because you are from the field, you have work in the input side.
Yeah. So, soil testing also, soil testing also is something which is something we are also working. And organic and not non-organic, I don't think so. It will make any much difference, because in organic crops, the real organic crops are crops where you don't use pesticide at all.
Right.
So maybe in that organic farm, your irrigation device will be of much use than any of your pesticide and disease model, right? So
Right, right.
that one device can be well fit to the organic farm, but in real organic farm, they don't use any disease or oh sorry, any pesticides. So disease model, pesticide model will not be much use.
Right.
That's
So one more question was, is IoT technology used everywhere? Yes, it is used everywhere. I
yes,
mean,
it's
in fact, in fact, if you go to US, and one point is also that in US also, it's not like that everybody is rich. Government of, I mean, US government is subsidizing the smart farming techniques, all these big tractors from John Deere to everyone a lot, right? We don't get to hear about that, but there also a lot of subsidy is being provided by government. So government has to be the key player in making this technology available to the user by helping the startups also, right? So that was one. Yield, somebody asked about the yield forecasting some time back. So yield forecasting is again a complex topic. It depend upon, are the people following the best practices, it depend upon the satellite images, it depend upon the if there's some disease prediction also. So yes, all this precision agriculture can be helpful in yield forecasting.
Yeah.
There's one.
I'll add, I'll
Yeah.
add to it on yield forecasting as well. I was reading that question. So, so there are two basically two kind of smart farming you must you witness in today in agriculture. One is prediction and second is detection, right? So what we are talking, what Fasal is doing, or maybe what a few other companies are doing, they are into prediction. Now, when we come to the detection of your detection services, where disease and pest pressure are detected based on satellite imaging, right? Basis that also, if you have used complete end-to-end features of that IoT device, I'm sure they are days are not far where you will be able to uh, uh, predict your yield as well, right? So yield forecasting is something is very much possible, and because you know the crop, you know the stages of that crop, you know what kind of disease and pest um, are there, and if you are able to farm precisely, you can even predict the yield as well. So that should not be a really challenge. The biggest challenge is to uh, is to digital intervention in the crop growth stage. That is the biggest challenge of what I see.
And yield forecast is also means nobody. I think nobody is asking about the very accurate. All the forecast are always like plus minus 5-10%, right? So yes means forecast need multiple interventions, satellite data, weather forecast, weather prediction, precision agriculture. So I think one more question was this question came that most of the farmers are illiterate, right? How means that can be removed. So farmers are illiterate, but they are means the old farmer are illiterate, but they are not with less experience. Probably they have more experience than us. Means I recently met a farmer in the North India, and he was more like 55 to 60-year old, and he knew about micro and macronutrients. He knew about why irrigation is required in a specific manner because they are growing some crops. So for for those farmer who are illiterate, government of I think this is where government role will play a very major role, and the NGO and FPO who are working, they are working on making these videos, which is helping farmer to understand that they have to be in parallel or in sync with that technology. And I think Jitenji, you want to add anything over here?
Yeah, yeah. So I was just because recently our new customer, uh, uh, he's 82 years old, right? That I mean, just a month, a week, couple
Hmm.
of weeks back. So maybe literacy will obviously will have a impact because he needs to read and read the advisory which comes on which is sent on his phone. But I think there's a difference as far as farming concerned. Being illiterate or being wise, these are two different things. But I what we see, all farmers, almost all farmers use their wisdom, even though they are not illiterate, but they use their wisdom. If they see value in this something which is helpful to save on his cost, I think his children and maybe somebody who is literate in the family help him to read and follow the messages that we send. So that remains a challenge, but yes, as we said that the it has his own time. He'll take his own time as long as farmer sees the value of using this technology. Literacy may not be a bigger challenge in coming years because his somebody can in family can do that work for him.
It's very true. It's very true. I think this is very true that even though the farmer is illiterate, but their family member, and it's specifically after COVID, when people are getting back to their hometowns, a lot of people are entering into farming. So one more question was there. This was a long question that for 1 or 2 acres or more farm, there would be one IoT hardware devices and the number of sensor connected to it. How the sensor are connected, wired or wireless. So mostly your scope is to install the complete system and provide real-time crop advice to farmer and charge annually for it. Do you also provide complete solution if FPO or group intend to buy it and carry out services by themselves? So yes, these devices can be wireless. Again, this is where it become again a bit tricky that what variable somebody is important in. If you are interested in irrigation, the device has to be installed as per the irrigation planning done by the farmer. If somebody is interested in micro weather, as in temperature, humidity, pressure, rainfall, leaf wetness, wind speed, wind direction, probably a device can cover a bigger area. And you can think of whatever precision farming is doing as a enabler for doing the next generation farming. So FPO can install these devices, FPO can use this data to provide a better advisory, which right now is not possible in absence of these devices or in absence of precision farming. So yes, FPO can use these devices, FPO can utilize this data. If they have some agronomist, they can utilize this micro weather and soil data to provide better advisory to the farmer. Jitinji, any
Yeah,
input?
I'll add to it this question. So
Yeah.
currently, as I said, it's a cross learning for farmers also and people like us also. So internally, I as I said, the innovation, the feedback that you get, the challenges that you face on the field, we also come back and see how can we improve on this, right? So Fasal is also working, and I'm sure you will hear that soon. We're also working to remove this installation challenge on the field, and how can we device be wired or wireless. So we have worked tirelessly. Our product team has worked on it, and we are coming up with a solution where this is not a challenge anymore. Maybe in couple of months or 2-3 months, you will see that installation, which was one of the biggest issue, will not be an issue anymore on for device. Yeah.
I think there are no more. Ginger is the list of the crop covered. So I like to add a couple of things over here. Crop specific things are mostly the disease thing, right? Disease and irrigation thing. So if you are monitoring the soil moisture, multiple crops can be added. So once you are gathering this data, means you can add more crops. Yes, that is possible. Ginger can be possible, but again, you need to have crop specific expertise also. You need to have people who understand the crop. But yeah, there's a possibility of adding more crop in the system because you are possibly measuring every possible thing which is required to be measured in a precision agriculture in the farm, and then you can manipulate this, you can compute data according to the crop. I think there are no more question. Kaushik.
Yes, sir. I kept in the WhatsApp group all the questions. So if you just want to go through that, if you have missed anything, I think yeah, you can add on that.
Grow back farming can be incorporated to grow back farming. Grow back farming can means somebody explain. I think it's also time, so we need to close on that. Grow back farming, if you can somebody explain on that. Grow back as in the mushroom farming.
I shall unmute everyone. Maybe a couple of more questions shall come.
Okay.
Yeah, I've unmuted everyone. So audience, please come up with your questions. Thank you.
If means yes, sir. Because
Hello.
yes, sir, we can hear you.
Yeah, I would like to ask Shailendra or maybe Jitendra Singhal, that will your company would be interested in associating with the horticulture growers here in Ahmednagar district? And as a KVK, we are also providing support to these growers in many different ways by providing advice and other facilities. Can in such a small growing pockets, like in small clusters, is IoT be utilized in a better way for these horticulture growers who are in a small cluster, or maybe some FPOs are there working in association with our KVK? So I suppose the cost is rightly mentioned as to how this can be transformed into an actionable kind of activity here for supporting the farmers in our area. I hope that Mr. Jitendra Singhal and Shailendra successful in setting up IoT-based support center for the farmers.
Kaushik, you can mute. You can mute everyone. Means I think Jitenji can go first. He can answer,
Yeah, I've
and then probably.
unmuted everyone.
I
You can
couldn't
come up with your
hear that
questions.
question.
Okay.
Was trying.
Jitenji, you can go ahead. Means you can add, and then I'll add to whatever question has been asked.
So what was the question? I couldn't hear that question. I'm so sorry. I was
Yeah,
trying to,
just
but the voice
wanted
was
to.
too low.
Are you able to hear
Me
me now?
repeat.
Yeah.
Let me repeat. So he's from Ahmednagar KVK. They want to work with you, the farmers, horticulture farmers in their area.
Yeah.
Okay. Okay.
He wanted what is the procedure, how you can or they can approach you to take it forward.
Yeah. So what you can do, you just I'll share my number. Maybe after this call, maybe, you can call me. We can then speak over phone. We have
And
uh, we have the process where you can be onboarded on this particular thing.
okay,
Yeah, I
is
think
there
Kaushik can share our email ID with the people, and then
Yeah.
we can put all these queries over the email directly.
Yes, sir. Sure,
One
sir.
more,
This was the, if you
yeah,
can see this photo, this was the photo I was talking about. He is our recent
hmm.
customer. Can everybody see this?
yes, we can see it.
Yeah.
yes, yes.
So he was our recent partner for this customer for this, and this is in Arangaon, Ahmednagar.
So this one more question. I think somebody explained for mushroom farming. What equipment do you provide for monitoring temperature, pH, humidity, bacterial and fungal contamination? As far as I know, for the mushroom farming, one of the most important variable is temperature and humidity. In fact, I know people who are using, in fact, the air conditioner to maintain that thing. So if somebody is monitoring temperature and humidity, that can be useful for the grow bags or in the mushroom also. I have seen a technology.
Anything for during the contamination?
Sir, contamination. There are no. At least I don't know about the sensors that contamination is there. Contamination for me falls under the quality thing, and I think this is where there are some more startup who are working.
Okay, if you can share any references, it will be helpful because we could not find
I
any on it.
think contamination, sir. I think we can. There's a big startup, AG Next. They are working tirelessly behind that. We can probably approach them. They are working in the quality produce, so they are targeting spices, tea, and every other thing. So you can approach them. AG Next is a company based in Punjab,
AG,
and one more- AG Next, AG Next.
AG, next.
Sir, I am just typing in the box.
Yes,
AG
sir. I'll keep in
Next.
the chat box, sir. The link
Yes,
is kept in the chat box.
Shailendra sir,
Yeah,
can I ask one question?
yeah. Please go ahead.
Conformia Agribusiness Private Limited. I just asked one question, but I didn't. It didn't get addressed. That's why I want to ask. Like, as
Sorry.
far as small farmers and marginal farmers are concerned, what is the increase in the cost, total cost, if they want to shift to your technology?
They want to. You're talking about a group of farmer. Or you're talking about an individual farmer.
2 acres land.
Sorry, sir. I think I missed you in between. Hello.
Like any small and marginal farmer want to shift to your technology, then what
Right.
is his increase in total cost as far as total other cost is concerned? आपके
Okay.
टेक्नोलॉजी को उसमें अगर किया तो ओवरऑल कॉस्ट उसमें कितना इंक्रीज होगा?
Sir, overall
Because I
cost.
I also
Overall cost.
हाँ हाँ,
Please,
because I
please
am
go ahead.
also
Please
from
go ahead.
Ahmednagar. I'm also Pasa, and we are also into like agribusiness, working in agribusiness field. So that's why I asked.
Sir, there are multiple ways it can be done, right? So about the ROI, that what I am getting out of that, right? And if ROI is good, people can pay. Now this is where I think multiple economical model can work out, which I was mentioning earlier. For example, you are a grower, right? You are working with a group of farmer, and you are working in a specific cluster or specific area. There are few variables which will remain same in that area, as in the air temperature, air temperature, air humidity might change, but rainfall, wind speed, wind direction, and solar radiation will remain same, right? So one interesting model can be, that is what we called as hub and spoke model, that you have a
Mhm.
weather station installed in the center of the village or in the location, and then you have specific devices installed in the specific field, right? So device
Mhm.
cost can vary between 10,000 to even 20 to 30,000 rupees also, right?
Mhm.
Which is installed on the individual field, right?
Mhm.
And then you have one weather station which is installed in the center of the village, which is measuring the variable which are not very much changing. Rainfall will not change with the radius within the radius of 1 kilometer, 1.5 kilometer, right? Wind speed will not change in that area. Solar radiation will not change in that area. So there are multiple models that can be worked out. What you can do is you can drop us an email. We can discuss on
Uh-huh.
that in detail, right?
Okay, Joshua, because my question is specifically about like if you concerning about sugarcane, like most
Hmm.
of farmers in our area grow sugarcane. So their
Right, sir.
annual cost for sugarcane production is 40,000, and if they
Hmm.
shift to your technology, what is their annual cost? That's it only.
So
I
I
just
get your
want.
point. 40,000 per acre, right?
Yes, 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 yes. So what
Yeah.
will
So
be your
you
cost
have
for
our
that?
email ID.
Yeah,
Yeah,
I
you have
also
our
have
email
your.
ID.
I've
You
shared in the
can.
chat box the email IDs
Yeah.
of the respective speakers. Yeah,
Yeah.
or
We
else
can take.
always we can also talk if possible.
Yeah. Sure.
Yeah, thank you, sir.
Yeah, aquaculture is there. So for aquaponics or people who are doing fisheries, the aquaculture is there. Savitri, Aquamonk, and there's one more startup which was funded by Omnivore a while back. I mean I forgot. People will know their name.
Irvaka. So it's
Irvaka, right?
Irvaka.
Yeah, Irvaka. So they're also there. Okay, sir. Cost of the device, sir. Anybody who wanted the cost of device or cost of the implementation, you have our email ID. You can approach us
Yeah.
over the email. I think this was more like for on making people understand that what precision farming is, right? And for any startup, for any company who is working, cost is one of the factor, right? And it always depend upon at what level somebody is doing production. So hardware cost is one, right? So you also know that in 2001 the smartphone were quite costly, and now you are getting them at 6,000 rupees. It is a patented. Yes, some of the technology is patented from both. I think from our side also and from Jitin's side also.
Yeah,
One more
I
thing, I
I
think.
will I will also add here in cost. So that is where, I mean, as we progress, because this is a very new concept in India, right? As we progress and uh, we innovate and develop on what currently we are doing, right? So cost is something is one of the biggest factor uh, uh, for farmers in India, right? So that is something I think um, uh, has to be come down so that any and everybody can afford that cost. So like somebody was saying for sugarcane, right? So their sugarcane, the total expenditure in sugarcane is hardly 1 lakh rupees or 1.25 lakh rupees or a hectare, right? He may not like to go to install a device for 20-25,000 rupees, 30,000 rupees for now, but obviously um, as we move ahead, as this concept mature, the learning curve improves. I think cost is something where, and an intervention from government, cost is something which can be uh, made possible to affordable for anybody, for everyone. So that is
Yeah,
something.
sugarcane is a crop basically which is very much water intensive, and it's mostly grown in Maharashtra region, which is anyway is a drought prone region, right? So at some point of time, government definitely is going to implement some clauses where people are using a specific amount of water. And in fact, I think I knew the stories where people are migrating from sugarcane to some other crops. So this technology has to be used because it also impact the quality also.
One more thing from my end. This is Yuvraj again. So one thing is
Kaushik, any other
affordability.
question from anyone? I think we are done with the question. No new question are coming.
Yes,
Mr.
yes, we can
Yuvraj
close it.
Hello,
is
this
One
Sandeep.
question from my side, sir.
Hello.
Is there any credit linkages, sir? Are you giving it on credit? Because most of the farming activity, they will be getting the money after the end of the cycle.
So we're not giving any credit for farmer for now, but certainly we are working. How can we financial assistant uh, can be given to him? So that is something that we are working on few models. But for now, that's no credit. But we understand this fact that farmers basically earn money after the crop is harvested. So we are working on some modality where financial assistance can be given to him.
That was the motive of the question. Is there any way you are working on? Is any way any schemes or a government or a non-governmental NGO CSR funds where they are pitching in to make it affordable and make it upfront so that it can be paid in the installments or later or service based, even if
Yeah,
the cost
yeah,
of the
yeah,
depth is high. Yes, sir. That's it, sir. Thank you very much, sir. I think it's a very informative session.
yeah. Thank you, everyone. Thank you so much.
Hello, hello. Yeah, Mr. Sandeep, go ahead.
Yeah,
Thank
I have
you.
I have a specific question. So all these we have, heard, listened to these seminars, and they are very fabulous seminars. But my question is that there is a farmers business network in USA. What they are doing is basically they are, integrating all the data from the various farms, and they're analyzing all the data, and bringing out, we can say, drawing out some insights so that may cater. Hello,
Yes, sir. Please
hello.
go ahead, sir. Please go
Yeah,
ahead.
so okay, so my question is, the startups are, catering the specific services, like, agronomic extension services for irrigation, or you can say some soil management, or some kind of a crop protection money management. But what about now, all they are operating in a fragmented kind of a thing? Okay, is it possible, or is it possible, or is there anything like technology consortium for precision farming, where various technology startups come together, and they incorporate their solution in such a way that end user, maybe a farmer, will get a complete solution, like a total management of a crop, right from land preparation to the harvesting, and then waste management and all these things in between.
Either of the speakers can answer the question, Mr.
Yeah,
Shailendra or Jitendra.
I can add that this is the answer can be very elaborative in this. The complete agriculture value chain is very big, starting from the land preparation, selection of seeds, the input which grow into the land. Then after that, the cultivation, the nursery, what kind of then the irrigation, weather, then harvesting, what kind of instrument are used in harvesting, then where it is stored, the mandi prices, and to which it is sold. Right. So it's very long. It's very big agriculture value chain. So people are means partnershiping. People are doing partnership with different providers. It's not possible for a startup. It has to be an expertise area, right? Means it has to be a combination amalgamation of different startup. Yes, you are correct. It has to be amalgamation of different startup working in different field, getting together to provide a complete end-to-end solution. So for example, if I am a farmer, right, I should get the best quality seeds. I should get the input on what needs to be done, what are the best package of practices. At the end, somebody should connect me to the end buyer also, and I should be able to sell that thing on maximum on the best possible pricing. So people are working on that. It might take some time because every startup is working on their specific field, right? Means they want to get them, first of all they want to improve, and then they can come together. In fact, people are working on that. All this FPO is definitely one example where they are coordinating with multiple startup. They are providing end-to-end advisory or end-to-end services to the farmer which are working with. So government of India, the aim of government of India by next 5 years is to have almost like 10,000 FPO. So FPO is definitely something that we are talking about here. Jitenji, you want to add anything?
No, that's fine. Yeah.
Yeah, I have a question. What about the interferences or disturbance by livestock, field or in plantation?
Which thing, sir?
The livestock interferences of the sensors or whatever we are fixing in the field or in the plantations, because wild or domestic animals and people, everything, how it is getting.
Sir, I will add some. I will
I have,
almost like
yeah,
almost like two weeks back, I got a news from Kolar region that the elephant has entered inside a farmer field. They have destroyed the whole field. At the same time, they have destroyed the device also, right? So one answer can be you cannot do anything for that. Means if a elephant entered inside a field, they will definitely destroy the instrument. Second thing is what can be done as a precautionary measure. This is more like a hyperlocal thing, that once the instrument is installed, you can have this wired wiring around the sensor, so that at least uh, 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 animals like means goat or small animals are not means hampering the device. Another question is, again, that question came to us, is that what if somebody can steal the device? So nothing can be done against the stealing. If somebody comes to the point where they have decided that they want to steal, they will steal, right? So these are some of the factors which are not possible as of now, at least at our end, to be catered.
I think that should answer the question, Mr. Sudhakaran.
Yeah. Thank you.
Yeah. And yeah, thank you for all the questions as well as from the audience as well as the speakers. And currently, like I request Dr. Saranan Raj, Director Agricultural Extension of Manage and the CEO of Manage CI, to give the closing remarks. Thank you. All right, some technical issues are on there. She'll go with like today it was a great session out there, and we have a lot of conversations with the speakers as well as the audience. And the Managed CI team thanks the speakers for sharing their experiences and all regarding their precision farming experiences. And we take this opportunity to thank Director General of Manage and Director of Agricultural Extension for all the support and all our endeavors, and also thank the administration team as well as the accounts team. And thank you. We shall also, send social media updates on our social media handles, as well as we'll also send the presentations and the YouTube links shortly. Thank you.
Thanks, Kaushik. Thanks, everyone, for your time. And if you have any question, you can always come back to us over the email.
Yes, sir. And emails have already been provided in the chat box. So once again, I'll keep it in right now so that it will be easy for all. Yeah. Thank you.
Yeah, thank you. Bye. Good day, everyone.